In Java, as well as other languages, the if statement follows the simple principle of do something if some condition is true. Let's flip a coin. We'll make a char result variable and set it to capital H for heads. Say we want to print out the whole word of the result, so print out heads if the result is H, or tails if the result is T. The first thing you'll notice, the stuff in the parentheses of an if statement always seems to be a Boolean value. That will always hold true with if statements because they either have to do something, meaning whatever in the parentheses evaluated true, or not do something, meaning whatever in the parentheses evaluated to false. Then you'll notice the code inside the curly braces is only done if the condition is true. So tails never gets printed in this code because the result never equals the character T. If your spidey senses are tingling that the result for flipping a coin will always be heads or tails, so there's got to be a better way to express one condition or the other, there is indeed a way to do that, but we'll save that for the next video. In Java, like in other languages, the if-else statement is just adding on an extra layer to if. If still follows the same principle of if a condition is true, then do something, otherwise run the next line of code. What else does is says, if every previous if clause before me was false, then do the code inside the else statement. We'll introduce this coin flipping example. You have a char result variable that will be capital H for flipping heads. If the result equals capital H, we'll print out heads. If you're at all familiar with coin flipping though, it's at this point that we can use else. Since the coin will either be flipped to heads or tails, if you didn't flip a heads, the result has to be tails, so this is a prime situation to use else. So else, print out tails. That's how the if-else statement works in Java. The else-if construct in Java will be demonstrated with the classic grade example. A student's grade is stored in the grade variable and we're determining what letter grade to print out. If grade greater than or equal to 93, then print out A. This is where the else-if comes in. If the grade is not greater than or equal to 93, then ask the next question, which would be, is grade greater than or equal to 85? Now that might be the case, in which case you'd print B, but if it's not the case, you'd ask the next question, that being whether or not grade is greater than or equal to 75. The concept of else-if continues down like this. Ask a question, if it's true, then do the corresponding code and exit the series of questions. If not, then ask the next question. In Java, as well as other languages, nested if statements are a way by which some code is only run if the condition prior to it evaluated to true. For example, in this code, if x is negative to begin with, y is never checked. That's the main function of nested if statements. However, if you look at the problem prompt for any length of time, one word will jump out at you, if x and y. The and was sitting there right in front of us, and we went right past it in favor of extra complexity. You can easily turn this code into a single if statement that says, if x is greater than or equal to 0, and if y is greater than or equal to 0, then print high. You get rid of the nesting and make the code significantly more beautiful. I always strive to avoid dogma in my teaching. Most of the time, nested if statements can be eliminated in favor of different structures. But if you find a situation where you genuinely believe the nesting to be more readable and clearer, then I implore you to run with it.